Hello, everybody. Welcome to the Raspberry Pi Foundation's Wintercamp coding session. I'm Mr. C, and I host the Foundation's weekly live stream. And with me today is Richard, who works on our Astro Pi space program. Hey, Richard, how's it going?
Hi, Mark. How are you? Really good to be here today for Wintercamp. I'm looking forward to seeing where people are going to be joining us from in the UK. So if you're watching this on YouTube, you can just type your comments in and let us know where you are and what troop you're with. If you're watching on the Scouts website, then you can click through to YouTube if you want to be part of the chat. We're going to be doing a bit of coding in Python today. We're going to be trying our hand at the European Astro Pi challenge. And for those of you who haven't heard about it before, here's a video explaining what it is.
In 2015, we sent 2 Raspberry Pi computers to the International Space Station. Now it's your chance to run your very own experiment in space. The European Astro Pi Challenge is an ESA education project run in collaboration with the Raspberry Pi Foundation. It offers young people the amazing opportunity to conduct scientific investigations in space by writing computer programs that run on Raspberry Pi computers on board the International Space Station. There are 2 ways to take part in the Astro Pi Challenge. Mission 0 is open to students and young people up to 14 years of age and can be completed in an hour or 2 by writing a few simple lines of code in the online simulator called Trinket. No special equipment or coding skills are needed, and all entries that follow program rules are guaranteed to have their program run in space. In addition, you'll receive a certificate showing you the orbit path of the ISS at the time your program was run. Mission Space Lab is a scientific mission for students and young people up to 19 years old. Once you're registered to take part and submit an idea, we'll send your school a free Astro Pi kit, and working as a team, you'll write an experiment using the Python programming language. The very best will be sent to the ISS to run for 3 hours and will be overseen by a European Space Agency astronaut. When your data comes back to Earth, you'll complete your experiment and write a report. The very best reports will be named the winners of Mission Space Lab. Both missions are open to ESA members and associate member states. So get your team together and get involved, because space is waiting.
Wow, that's amazing. So, Richard, you help organise the Mission 0 challenge for the Foundation?
Yeah, I'm lucky enough to be able to do that. Yeah, as you saw at the end of the movie there, the Mission 0 is a collaboration between the Raspberry Pi Foundation and the European Space Agency. So while it's not a Scouts activity, if you participate today, that will help you achieve your Level 1 Digital Maker Staged Activity Badge. You can see more information about the Digital Maker Badge at the URL that's on the screen below. If you're a leader interested in running the Digital Maker Badge, check out that URL.
Yeah, that's really cool. And so not only that, but everyone who follows the instructions today, and if you don't have errors in your code, which is a thing we'll go through and help you sort out at the end, then your program will run on the International Space Station, and you could possibly have your message, the one that you write today, seen by the astronauts up there. That's pretty cool, right?
Yeah, I never get tired of being amazed by how great it is that people can send code to the International Space Station. Not only that, but you get a certificate at the end of it that you can show your friends and family that shows you exactly where the International Space Station was over the Earth when their code was run.
Amazing.
There's only one thing though, to be eligible to have your code run in space, because it's a collaboration with the European Space Agency, at least half of your team has to live in a member state of the European Space Agency. So that's all the EU countries, the UK, and it includes Slovenia, Latvia, and Canada as well. You also have to be 14 or under, and you also need to get your permission from your parent, a teacher, or a scout leader. You can work in teams of up to 4 people if you like, or you can submit an entry by yourself. We don't mind.
Awesome.
Even if you don't meet those criteria, you can still take part, but your code won't run in space. You will still get a participation certificate though. So, and it will also obviously help you earn your Digital Maker Badge.
Awesome, that's cool. So one other thing that you need to know, everybody, is that if you choose to enter Mission Zero, then you're going to have to share your first name and the team name that you come up with today with the Raspberry Pi Foundation and the ESA, the European Space Agency. But we don't collect anything identifiable beyond your first name, and we promise we don't share your data with anybody else at all. You should check with the Scout Leader teacher or your parent that you have permission to share your first name. And you can see our privacy policy at the URL down here if you're interested or you want to check that out a bit further. So have a look at the URL if you're interested in our privacy, but we don't share anything with anybody else.
Cool. First thing, actually, this is probably the hardest thing of the whole activity, right? You've got to think up a team name. So your team name is what you'll use when you put your entry in, and it's also what will appear on your certificate. So think up a team name now, write it down somewhere, and also give it to your Scout Leader for safekeeping. So what happens with Mission Zero is all the experiments get collated together, and then they get sent to the International Space Station later in the year, normally around April time, and they get run in either April or May. So by the time we get all the data back and process it, have the certificates ready, it will be June. So you need to remember your team name in June, because that's how you're going to be able to find your certificate again.
Okay, cool. So that's a really good point, everybody. Do that now. So think up a team name for your team, or if you're running solo, that's fine. You can think up a cool team name by yourself. It's less of an argument to have, and write that down before we get started. Okay, don't get too hung up on it though. You'll have an opportunity to change it at the end of the session when we submit. So come up with something now. If you think of something better in the session, great. If you don't, then use what you have. So should we crack on and get coding, Richard?
Yeah, I think absolutely. Remember, if you get lost or stuck or something's not working when you're going through it, you can put your questions in the chat and we can talk you through how to share your Trinket Python project, so we can look at it and try and work out what's going on. Obviously, you can also pause and rewind the video anytime you like if you need a bit more time, and this video is going to be available after today for you to rewatch whenever you like. So don't panic if you're finding it a bit tricky. Just stick with it, and there'll be lots of opportunities to have another go or finish off later.
Awesome. And so the first thing we all need to do now is to head across. So if you're watching us on your laptop, you need to open a new tab. If you're watching on another device, then go to your internet browser and you need to open this website down here, trinket.io/mission-0. And what that will do is we'll open up the Trinket emulator, which I actually have up on my screen now. So I'll add that up so you can see it. So you should see something that looks a bit like this. And so this is the special Trinket emulator that we've got ready to go for Mission 0. You should see sort of like the coding window here on the left. You can see where I've got my code written here. That's already there when you open the Trinket. Don't be surprised if a little bit of code's there. We'll explain that to you in a minute. And then on the right, you can see here, I'll just zoom out a little bit so you can see it a little bit better. I've got the Trinket, so the SenseHat emulator on the right here. So this is actually a replica. Is that right, Richard? Just like the one that you've got in space?
Right, so the Raspberry Pi we've got on the space station are in these amazing custom flight cases, and I'm really lucky to have one of the actual replicas here. This is the rig that contains the Raspberry Pi computer, and it's got a load of sensors on there. There's a little hole here for a humidity sensor. There's some buttons for the astronaut to interact with it, and there's also an LED screen here, which basically it's really hard to see on the camera. It really doesn't photograph well at all, but there's 64 LEDs on here that you can light up, write messages on, put pictures on, all that kind of thing. So for the mission today, we're going to be using the emulator, which gives you an online version of the real thing.
Very cool. That's awesome. This video here is showing us the Astro Pi running in space. So you can see here we're moving through the ISS and we're having a look. This is one of the windows, the portholes that points out into space, and you can see the Astro Pi running code there, the little message flicking across. So we're going to write a scrolling message today, and you'll see it zipping across the screen. Here we go. So your message here could be seen by the astronauts when you run yours in space. This is exactly what we're going to have our one do when we finish the session today. So that's super duper cool. I mean, the thing about Trinket that we have is it's like an exact virtual replica of that unit that you guys could see in space there. So today we're going to pretend like our code is running on the Astro Pi you just saw and test the whole thing out. And then we're going to submit that program so that we can actually have our code run up in space on the actual machines a bit later. And we'll measure the real environment on board the ISS when you run your code. So there's some criteria we have to fulfill, right, Richard, in order to get the stuff going?
Yeah, the program is really simple. You can do it in just a few lines of code. It has to do basically 3 things. So the first thing is it has to read from that humidity sensor that I showed you earlier on here. So it reads how much moisture there is in the air on board the ISS at that time. That's the first thing. It has to display a nice friendly message to the astronauts up there, so they know the program's running. And we know that the astronauts, they're busy guys up there, but they do like to look around and see what the messages are being seen up on the screen are. So it has to do that. And also, and this is probably a bit obvious, the program has to run without any errors. There can't be any mistakes in your code. And the final thing is you're allocated 30 seconds. So your program can run for 30 seconds on the ISS. Right? It needs to be quick because we have loads of people who enter Mission Zero every year, like thousands of people. So we run these programs one after another. So one code runs for 30 seconds, the next program runs for the next 30 seconds, bang, 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 and so on. So that's why we give everyone just 30 seconds to do that. That means we can basically run 104 entries for each lap of the Earth for the ISS. Now, if it takes, 92 minutes for the ISS to do a full orbit, that's pretty quick, right?
Super quick. It's moving somewhere around like 17,000 miles an hour. So today's session, we're going to be following the written instructions, everybody, on the project here, so that you'll be able to run your code at 17,000 miles an hour. You can get the projects here at rpf.io/mz project. We'll just pull that up for you now. So if you have a look here, head over to this URL to get the project instructions, so you can do it again at any time if you want to follow those. And they're the instructions that we'll be following today. So if you prefer to follow along with those as well and watch the video, then you can just pop them up. And you, at the end, will submit an entry using a special classroom code. So you can see here on my screen at the bottom, it asks me to continue to submit my form. It's going to ask you for a classroom code to put in here. And the classroom code that you need to put in is going to be Scouts-Wintercamp. But we'll remind you of that again when you need it. We'll remind you of that. And you can submit any time now up until the 19th of March. So if you don't get to finish today, write down the classroom code, carry on doing your work and submit it, and we can still run your code in space later on. You don't have to finish in this 1 hour session at all. So should we crack on, Richard? Should we bring in Ozzy, who's going to code with us today?
Yeah, I'm going to drop out and let Ozzy take over now. I'll see you later.
Brill. Okay, catch you later, Richard. All right.
Hello.
Hey, how's it going, Oz? Oh, Richard keeps popping back. There he is. How are you, mate? You good?
Yeah.
Awesome, dude. So I'll just hide my screen. How are you, mate? Everything cool?
Yeah, it's good.
Ready to do some coding today, man?
Yeah.
Awesome. So you've got Trinket open in one tab and you're sort of like looking at me in another tab?
Yeah.
Is that what you got that set up? And so everyone at home should be doing that. If you're lucky enough, guys, to be watching on multiple devices or screens at home, then that's easy to switch back and forth. So if you're watching us on TV now and working on your laptop, very easy. But if you're switching between tabs today, don't worry. We're going to go really nice and slowly for you, and we'll explain everything as we go to keep up. So can you see, though, Ozzy, you've already got some lines of code in your Trinket there.
Yeah.
Yeah, cool. So everyone at home will have those as well, and they're just put in because they're boilerplate, everyone. So they're things that you will definitely always need to run your code, and so we've put them in to make it a bit easier. Just to explain to you what they do, the first one up the top there, where we've got from SenseHat, import SenseHat, what we're doing, guys, is we're asking the computer to go and import a module, import a library that we're going to need. So if I asked you, Ozzy, to go into the workshop that your dad's got at your house and go and find the reciprocating dingle arm made of prefamulated amulite, would you know anything about what that was?
No, not at all.
No, not at all, right? Probably not. But if I went and gave a book and that book had a definition of what that was and a picture of where you could find it, you could pretty easily take that book and go do that, right? Sweet. So that's what we're doing here, guys. We're saying to the SenseHat that I'm about to throw some commands at you, and if you don't go out and import this module, you'll have no idea what I'm talking about. You need to go and get the manual, bring it back, and then you'll understand. In the next line, we're saying sense equals SenseHat and these two brackets, which is called a method. So that method there, what we're telling is we're saying sense equals SenseHat, and we're instantiating an object, which is a fancy way of saying whenever I say sense, I really mean this thing here, SenseHat bracket bracket. Okay, and that tells the computer we're going to start using that. And whenever I use the word sense, I'm really writing all of this. So it's twofold. It also makes it mean, it means that we don't have to type everything out over and over again. We can just type this single word sense at the beginning whenever we want to call that method in. That's the instructions for the computer. And then the last line is sense.setRotation. And you can probably guess what that does. But just to explain a little further, on the LED screen inside the Astro Pi, it's actually turned 270 degrees or 90 degrees anti-clockwise. And so we put that code in to flip it back and make sure that what you're reading is the right way up. So does that all make sense to you, Oz?
Yeah, it does. Yeah.
Awesome, man. Cool. And you've done a bit of Python coding before, right? At Coder Dojo and stuff like that? Awesome. So it's good. It's nice to have an old hand. I've seen you code before, man. I remember when you came into the workshop at the office and we were building all sorts of crazy gadgets and things out of electronic bits and pieces.
Yeah, I remember that.
So yeah, cool guys. So if you're a fresh beginner, don't worry. This is a really nice, easy project. Don't feel like you have to try and keep up with Ozzy as he types like a demon, but we're going to crack on now. So let's go into the instructions, which you guys should all have in the project site there. And so you see you'll be looking at the introduction page, and it has a little trinket picture of there. So we're going to skip forward to display a message, which is the third step in the instructions. So if you're looking on with the instructions, then you can just skip to the third step, which says display a message. We've got our sense emulator open and our 3 lines of code. So the first thing we want it to do, Oz, is why don't you give it the sense show message and then type something in that you want. And I'll do the same at my end. So you can type anything that you want in there, and you'll see that what Ozzy's doing is he's got sense.show_message. So you can see we've got the sense at the beginning. Again, we're calling that method. We're telling the computer we're going to use this set of instructions. Sense.showMessage, and you can put whatever message you want in there as long as it's in speech marks. So Ozzy's got those speech marks to make a string, okay, and you can see that his message is there. What have you typed in, Oz?
I've got hello astronauts.
Awesome. That's cool, man. And like I've done a similar one in mine. Mine just simply says hello world. I'll switch over to my one so you can see it. There we go. So I've got hello world in mine. And as long as your message is inside these speech marks, everybody, when you click run, and we'll go over to Ozzy's again. So Oz, when you click run, what do you get at the top there? There we go. Awesome. And so we can see that scrolling message. That's cool, man. Well done. Nice. Hello, astronauts. And so you guys can do the same. Make sure your message is in quotation marks, the speech marks, or it won't run properly. It will give you an error. But once you've got your message rolling, we can kick on to the next step. So remembering, everybody, that when you're typing a message, you can use pretty much only the Latin character set. Anything else will come up as a question mark. If you type something in that it doesn't like, it will come up as a question mark. But it's very rare that we come up with a symbol that it can't do that. So your message is going a little slow, Ozzy. Should we speed it up?
Yeah.
How do you do that, man? Do you know how to change the speed of our message when it scrolls past?
Don't you use scroll speed?
Yeah, you do, man. Well done. Yeah, so pop that in at the end.
Scroll speed equals. Then I'm going to go 0.1 and see what that's like.
Nice. Okay, so let's see what happens when we try and run it. So that's 0.1. Cool. So what you're setting there, when Ozzy's put his scroll speed into his message at the end there, we're setting a different parameter. So we're telling it, show my message, hello world. Now, how do you like your cups of tea, Ozzy? If I was going to make you a cup of tea, what would you want?
I guess with milk.
Milk and sugar?
Yeah.
1, 2, how many sugars do you take?
1.
Okay, so Ozzy's default set of cup of tea is a white and 1 cup of tea, right? So if I just type sense.cup of tea, I'd get a white and 1 cup of tea, but we can change those parameters. So Ozzy could tell me, make me a cup of tea, but I want 3 sugars, or I want 9 sugars, or I want goat's milk, or I want orange juice in it, right? You can change a certain parameter, and that's what Ozzy's done there. He said, I want it to scroll at a different rate to the normal one. And so you put in 0.1, which is actually the default number, coincidentally. It actually takes 1/10 of a second to change the frame of what you're looking at. So you'll get 10 frames every second. Now, if you change that to a smaller number, Oz, like 0.05, that means your message will go faster.
So yeah, that's much faster.
Awesome, man. And if you make it even smaller again, what happens?
It goes even faster.
Totally. Bam. And now it's like borderline unreadable, but that's really cool. So if you're playing around with your numbers as well at home, make them really big and see what happens, really small and see what happens. And it will just change the speed of your message as it goes. We can do a few other things with the display message. We can like change the color of the words, Oz. So do you know the parameter for that? I bet you do.
Is it text underscore color?
Sure is.
Spelled like that.
Nice one. So it's text underscore color to make some color in our parameter. So now, before we do that, we have to understand a little bit about RGB color. So all the colors you look at on your computer screen, everyone, they're made up of a mix of red, green, and blue. So all of the colors you see have got a certain amount of red, a certain amount of green, and a certain amount of blue to make that color, right, Oz? Yeah. So if I had something that had all of the red channel full and none of the other colors in it, what color would I be seeing?
Would be seeing red.
Absolutely, yeah. And so with those 3 channels, we can mix and match each of the numbers, red, green, and blue, to get up to 16 million different colors. Now, all of those 3, R, G, and B, can only go up to 255, everyone. That's the max number you can put in when we're about to play with this. 0 to 255. Anything outside of those numbers and it won't work. Okay, so your code just won't really run. It will say, I don't understand what you're trying to do. You'll get an error message. So before we do that though, let's set a color, Oz. So go up above your sense.show message and type in what color you would like your text to be. What color do you reckon, man? You can make something crazy.
Green.
Yeah, awesome. So you're going to do green, I'll do mine blue. Okay, and you see here, Ozzy's setting that color. So he's telling it what he wants is none of the red channel, all of the green channel, and none of the blue channel. So colors are always RGB in that order, RGB. So if you're changing the first number, that's how much red you're going to get. If you're changing the second number, it's how much green, and the last number is how much blue. So if you put in 02550, you'll get all green. Okay.
Yeah.
And then at the end, you need to tell it that you want it to be that text color. Absolutely. So you got Ozzy's one there going nice and green already. And then you can see my one here. So I've got my one, hello world. So my color here says blue equals, and I've got the color set up here, 00255, remembering it's RGB. So this one will come out blue. And then I also need to tell it at the end of my code that blue is the color I want it to set. Okay. And now, if you're doing this, I'll run my code so you can see it. Okay, run. There we go. And you can see my text is coming out blue, and going still going quite like fairly slowly. Let's see if I can get it to go a little bit quicker. Okay. Hello world, and it's all blue. So I could also make another color here. So if I wanted to go red, I'd go like that, all of the red, none of the green, none of the blue. Okay, so that's what we've got in our color here. And then over here, I'll just change it in my code to red. And now instead of pulling my blue color, it's going to pull my red color. All right. Ozzy, if I've got all of the red to make red and all of the blue to make blue, how do I make purple?
You'd put no green.
Nice.
Great. Yeah.
Absolutely. It's just like you think it is in real life, right? When you take red paint and blue paint and you mix them, you get purple. So if we go 255 for red, no green, and all the blue. 255 is the largest I can go, so I'll do that. Now if I change this here, go that, and then run it again, and we'll get purple text come through. Cool. So you at home, keep playing around with those sort of color numbers. Make up a color, right? See what you can get it to do. And once you've done that, we're going to try and now paint a picture. So we're going to use this 8x8 grid that we have. So you can see that the little lights on your sensor emulated there, they're 8x8. There are 64 of them. And we can program each light bulb individually to show a specific color at a specific time. So what we're going to do now is we're going to do that. So we're going to display an image, and we're going to have to code that up. So if you go to your instructions, it's the 5th step in the instructions we're about to work through now, display an image. Okay. And we're going to make it a little bit more efficient. So Ozzy, how could I make my list of colors more efficient than it currently is? How can I make it easier for me to work with?
Would it be just one letter variable name?
Right on, man. Very good.
The whole letter name, whatever.
Totally. So like Ozzy says, if we get rid of these ones, now instead of having to type purple all the time, and you'll see that my trinket has popped up yellow saying that purple isn't defined. It doesn't know what I mean because I haven't set it anywhere else in my code. If I now change that to just P, okay, and I run it, it will still come out purple, but I've had to do less typing. I can also just change that to R and do the same, and now it's going to be red. Okay, and that's the code that we're going to use in a minute, everyone. So when we come to this to drawing a picture, you're going to draw a set of 64 letters that will determine the colors that you need. Okay, so set up like at least one color before we move forward. So you have to have like, you can use the ones that I've got on screen now. So you can use blue 00255. And we'll crack on. So we've got our message here. And so above our last line, we're going to tell it to draw a picture. We want it to create an image for us. So to do that, we're going to type the word picture and then equals. Oops, I'm in the wrong window. Picture equals. Okay. And then we're going to build a list. Do you know how to build a list in Python, Ollie?
It's square brackets around.
Square bracket, man. Very nice. So as Ozzy says, we put in a square bracket here, and it sets our second square bracket because Trinket is nice like that. And then we're going to go to the next line. So the reason we go to the next line, everyone, is because we're about to draw a square, and we want to have all of the left-hand lines of our square line up so that we can see in our code just like it would look on the screen when it pops up. So we're going to do an 8x8 set of letters. And what we need to do now is if you just draw a little picture on a piece of paper, if you've got one handy. So 8x8, I'll draw an 8x8 grid here. Okay, so you can see here I've got an 8x8 grid on my notebook. And then in there, what we can do is we can just color in a few little things. So I'm going to draw a little space invader. Okay, so you can see I've just colored in a few spots here. Right, and that's a little picture that I've got, my 8x8. Okay, so that's just my little space invader. Yours could be a smiley face, could be anything that you want, any sort of picture you like. Okay, just color in a few squares now. You have a go too, Ozzy, if you've got some paper there, man.
Yep.
I'll draw a little character that we can use. And then in just a minute, everybody, once you've got your picture ready to go and you've drawn your little character to put on screen, if you can imagine that every one of the squares that you've just colored in, we're going to set that light bulb to be a specific color on your sense hat. And then that is going to shine through. When we tell it to show our image, it will pop up all of those light bulbs that you've set as a picture, and it will show it to you on the screen, which is a really nice little effect that we can do. So rather than having a scrolling message to display something, when the sense hat measures the environment, we could have it show a picture of a sad face if it's too hot, and a smiley face if it's nice and cool, or anything like that. It's much easier for people to see those sorts of warnings. So I've got my picture, and I'm going to crack on. Have you got a picture as well there yet, Oz?
Yeah, I've got one I can do.
Awesome, man. So you can see in my one here, on the first line of my picture, the first 3 squares are blank, and then there are 2 coloured in ones, and then 3 blank ones. So I'm going to emulate that in my code now. So you can see here, I'll just do that. So 3 blank ones. So I'm going to put in B, B, B. Okay, everything separated by commas. Oz is really important. And then R, R. Okay, and then B, B, B. Awesome. Okay. So you can see here that the first 3 light bulbs, when I set it, are going to be blue, then 2 red ones, and then 3 blue ones. And I'm going to do the next line of my code. So once I've got those 8 in a row, I go to the next line and do the next 8. And so you can see here, I've got 2 blank ones, followed by 4 coloured in ones, followed by 2 blank ones. And then just so on and so on until I'm finished doing my picture. So everything separated by commas again. Okay. Actually, I'm going to do something a little bit cheaty. So I'm going to take this and I'm going to copy it. Okay. And I'm going to paste it here. So Control-C to copy that line, and then Control-V. And then all I have to do now is change the letters where I don't want them to be. Okay, and another line.
I've got my picture here now.
Already, man. Awesome. Show us.
So I've got this like...
Wicked.
It's going to be a beach scene when I'm trying to get one.
Very cool, man. That's wicked. Nice. And so how would you get it to show your image in the code, Ozzy? Now that you've got your picture there, how are you going to get it to show?
You sense dot set underscore pixels, and you write in the name of your picture. So for me, it's picture. And if we run this, we just comment out this line so it stays on.
Nice one.
So I'll run it. It's got like there's like
Amazing.
trees.
That's awesome, man. Very cool. And so when you said you commented out your code, Ozzy, what did you mean by that? So just for the folks at home who don't know the lingo.
It's because if there's no weight between these two, so what it will just set the pixels and then instantly go to showing the message. So you'll never actually see the picture. So with commenting out this line, it just stays on that picture the entire time.
Well, that's cool.
Because there's nothing to change. Another way of doing it is if you, at the very top here, you do from time import sleep. Then you put like a sleep, and then in the brackets, however many seconds you want it to sleep for. So I'll say 3. So that will mean your picture will stay on the screen for 3 seconds. 1, 2, 3, done. Then it will go to your little message there.
Very cool, man. And so you can see there when Ozzy did at the top, he imported his sleep. So from time import sleep, right? That's a very important thing. So we've gone away and we've told the computer, go away and pull up for me a new book. So you'll see here, if you just go to the end of the first line and we go hit enter, from time import sleep. Now you don't have to do this one, everybody, for your code to work, but we're going to pop it in here anyway, just because it's a really handy thing to have for a bit later on when we want it to wait and maybe show our picture. But to actually enter mission 0, you don't need to use it. We're just going to use it here because it makes it nice. And you can see down here, I've got the same thing as Ozzy. So I've got my picture set up, and I'm hoping it will be my Space Invader, but I haven't tested it yet. So we've got set underscore pixels, and then my name is picture. So if you've called yours something else, as long as you put the name of your thing in here. And remember, if I get it wrong, it will tell me that it doesn't understand what I'm doing. Okay, so it's not defined. So make sure you're looking for those yellow parts. And then if I now run my code, you'll see, there we go. Got my message, so I'll stop and I'll run it again. We can see my little Space Invader pops up, there he is. And then I get my rolling message. Fantastic. So you guys at home, crack on with your pictures. And then see what we get from them. We'll add them in. Okay. How's it going, Richard?
Dad, you're muted.
I'm muted, yeah, I'm muted, thanks.
That's always the way.
Yeah, it's a great coding going on here. I just want to say that if people are following along at home, if you do want to leave us a message, if you're having any problems, you get in touch, please do click through to the YouTube chat and leave us a message on YouTube, and then we can have a look, slow down, we can go back over some of the things we've done, or we can even have a look at your code if you can share it, if you've got any problems going on there.
Cool. Awesome. Thanks, Richard. Just a good reminder. Yeah, it's true, everybody. We are here in the chat if you're finding it tricky. And remember, you can pause the video at any time, rewind, watch the whole thing again. It will be on the internet forever. So if you're finding it tricky today, that's fine. Watch along, get a good idea. And then maybe later on this afternoon, you can follow all the instructions and crack on with the project and then enter. You can enter all the way up to the 19th of March. You don't have to sort of like work through really fast and stressfully today in order to get it done, guys. Just remember that. So once you've got your picture there, and you've got sort of your sense.show message. If you are entering a picture today, then you will need to do the sleep that we told you about, just so that you can have your picture, like Ozzy said. If you don't have the gap after your picture, when it shows the message, it immediately pulls it off the screen, and the astronauts won't see the awesome artwork that you've put there. So do into the sleep if you're doing a picture, but we're going to move on now, and we're going to measure the humidity in the room using the Sense Hat, because that's essentially what it was designed for. While the LEDs are a really cool thing to play with, the actual thing was designed to be a sensor of the environment, so it can detect how warm it is, how humid it is, and we're going to feel the humidity or how damp the air around you is today. So the next step on that is to go through here, and we're going to have the Sense Hat try and sense that. We have to have a command that we give the computer to say, check what the humidity is, computer. How would we do that, Ozzy, do you think?
Is it find temp? I can't remember.
Not bad, dude. So we need to set up a variable first. So you would pop the command through a variable. So we're going to say, when you check the humidity for me, Sense Hat, okay, pop it in a jar that I'm going to call humid, right? So I'm setting up a variable here. I'm saying humid is going to be the thing that I'm looking for, right? So I'm going to put it in down here, actually. So set up my variable, okay? So a variable, everybody's like an empty jar that I write a label on. And so the label I just put on my empty jar now is humid. And so I'm going to say to the computer, what I want you to do is check the humidity, and whatever the value you find, shove it in that jar. If I ask you to check again later, replace the value that's in there with the new one, okay? So keep swapping whatever I ask you to check. And then anytime we want to know what the current humidity is, we can just look in the jar that we've called humidity, and the computer will give us the answer that it last got. And that's what we're going to do here. So we're going to say, when you go through and you start checking for the humidity for me, what I want you to do is to go and set that to humid. So sense.get_humidity. Okay. I got that. Hang on a sec. I'm just going to change my text up a bit. It's quite small, hard for you guys to read. There we go. So what I've got here is humid equals sense.get_. Why am I not typing? That's really annoying. There we go. Get_humidity. Okay, and then we put 2 brackets at the end. Okay, so that's telling us that it's a method, it's a command, it's a thing we want it to do. So humid equals sense.getHumidity. So every time you check for that, pop it in my jar called humid. Now we can round that off if you want. You don't have to do this part, but otherwise the humidity you're going to get returned is a huge long number because the syntax is very, very precise. So you'll get quite a large number. So in order to do that, we're going to tell it in our humid line here now. We're going to put our sense.getHumidity, the whole thing in a bracket, and we're going to say, I want you to take everything that's in that bracket and I want you to round it off. Okay, so we have round this answer off, sense.getHumidity, before you put it in the jar, before you store it to my variable. And I want you to round it off to 1 place. Okay, so humid equals our rounded off answer of getting the humidity, because we don't want to show the astronauts this massive jargony number that they're not going to be able to read. And it will also take up a good chunk of time in your code as well, which we don't want to waste because we only have 30 seconds. Okay. And then we can show the message. So we've got our so we're showing our picture and we're showing our hello world message. Okay. So we can add another line, or we can replace this one even. Let's leave our personal message to the astronauts in there. Okay, I'm going to copy that line and paste it because I don't ever really want to type anything out twice if I can avoid it. Okay. And then the next thing we're going to give it is we're going to tell it that I want you to take that answer, my humidity answer, and pop it in here. So whatever humidity is, show that to me as a message. So we've stored that value. Now bring that value back and show me it as a message. And so we want it to show _message, and we want it to be a string of our variable. Okay, now when we say string, that's a coding word for taking whatever that is and copying it exactly as it says it. Okay, so a string is when you take a series of values, so a series of characters, and you take them and stringify them, which means that they are now unchangeable. Okay, this is exactly how the computer is going to use them every single time. And we're telling it, take that human thing and make it a string so that I can fit it in as a message. Because if you see in my code here, that's what speech marks do. They make something a string. And so we're going to do that with our number. Okay, we're going to say, set that to be a string. So if I run my code now, I should get my Space Invader, then I'll get my hello world, and then it should display a number for the humidity for me, which is 44.2. Okay, so you can see here, we've got a humidity slider. So on your one, once you've got your code working, check for your errors, make sure it's showing you the humidity string. And then you can change the slider. So I'll put it all the way up to 81. And when I run my code, it should show me my Space Invader, show me hello world. And then the next thing it will show me is the humidity that I just set to be 82.6. Okay, so there we go. We set it to another one. Let's see what we get. So I'm about 31 here. Let's see if the SenseHat does it again. Space Invader, hello world, and whatever the humidity is set to now. So you can see that it's checking every time and changing that answer for me as it goes through. How's your one going, Ozzy?
Mine's going good. I've decided to get rid of the hello astronauts and just put it in. So what I've got is it displays my picture for 5 seconds. And then we'll say the humidity is in this string here. And then put a little plus sign, and then add your string humid.
Nice.
Not in, so it will run as one thing saying humidity is, and then whatever I've set it to, so 72 or so.
Oh, that's cool, man.
The humidity is, and then 71.80%, I think it is. Yeah. So I've just done that by taking my this humidity is, and putting a space between the ends. So this will be the just like usual text saying something, and then we have the add symbol, and then the string humid. This will basically add them both together into the same line of text.
Nice one, man. That's very clever. So what he's done there, so what Ozzy's done is really clever to join two strings in that way, where you've got one that's a text string and one that's a stringified value, and you just plus them together, use the plus symbol to join them together, and then we get that really nice little message that he's got. It's a really nice, clean message. It's much nicer than mine. So why do you think, Oz, when you set it to be like 31% like I did, or you set yours to be, what's your value set to be on your slider?
I've got 43 right now, but I'll turn it up to 92. 92,
and we'll still get some weird like 1 point decimal answer if you watch. Yeah. So you'll get an answer rather than the exact number we've set the slider to. We'll say the humidity is, and we'll get this slightly off answer. Do you know why it does that? There we go, 92.6. Do you know why that happens?
Is it just to simulate real life? How you know?
Yeah, man. Exactly. It's to simulate the fact that the sensor on the device itself has a slight inaccuracy. And so the people who made the emulator here went to the level of detail to put the inaccuracy into the program for you, just so it was as close to real as possible. Okay. So what we've got now is we've got a message that will run. We've got sense.setPixels picture, we've got a sense.show message, and we've got it displaying the humidity. So what you'll notice is if you go down, if you've got all the code that we have, and you go to the bottom of your script, you'll see down here that we've got 3 green ticks, okay? And my code lasts for less than 30 seconds. So if you want to, you can submit your entry now. Your entry is a valid entry if you've got the code that we have just done. Okay, so remembering that at the bottom, when it asks you for your classroom code down here, your classroom code will be Scouts-Wintercamp. Okay, so you pop that in there, and you'll see it says classroom code found underneath, just down here, classroom code found, teacher, the Scout Association. So if you write that code down, if you want to enter any time between now and the 19th of March, you can use that code to put your entry in. It will ask you for your names and your team name, and you can make those entries, no problem. So you'll see again, everybody, I've got my code. We've done a picture, which is really cool. It's not necessary, but it's a cool thing that we managed to do. Ozzy, your picture's way better than mine, by the way, dude. I'm super impressed that you're like, is that an oasis or a beach scene?
It's meant to be like some palm tree beaches, but
palm trees,
I don't really know.
It's wicked, man. It's very cool. Nice bit of artwork. So fast, too, to cobble that together really quickly. And so we've got everything. So I could submit my one if I want to now, everybody. That's no problem whatsoever. But we're going to go through and we're going to do a little bit of things to it just to make it a bit more nice. Sorry, a bit nicer, a bit more fruity, add a couple of cool things to it, and just to play around with the SenseHAT a little bit more, which is always fun. So down here, before my code begins to execute, so the first thing you'll notice that my code does is line 22 in mine. It shows the picture. So above here, before my script starts running, we can put all sorts of things in here, okay? What I want to do, though, is we've got our humid equals sense.getHumidity. How would you think, Oz, what would be the logic for if the humidity is too much, then show me one thing. If the humidity is too low, let's say you wanted to have different colored text, how would you have it if the humidity was low, be one color, if the humidity is high, be another color?
So I'd have it sort of, you do if statements. So if, then your variable humid is, let's say 45 is like the base humid. If it's greater than 45, then greater or equal to, then we can create a variable called text or text color, whatever you want. And then we set it to whichever color we want for it to be hot. So I'd say red for being, no, not hot, that's temperature. I say red if the humidity is over 45. But then that doesn't count for if it's under 45. So we'll need to put an else loop in there. So an else text color equals blue. So this will then set this will say if the humidity is over 45, the text color will be red. So our variable text color will be red, else the text color will be blue. I've just realized we want it in RGB values instead of the letter. So we do if text color equals 25500, which is our RGB values for red, and the other one is 00255. So that's the RGB colour for blue. And lastly, we go down to our line that says the humidity, whether that's just the humid or what I've got the humidity is. And instead of having your text colour as right now what I've got is green, we just change it to our variable, which for me is that. So now when I run it,
What did it like? Syntax bomber.
Yeah, you want
Good find.
code on there. So it will display my picture. Then, because I've set it really high, it will be red.
Awesome.
So then if I set it down low, then run it, it should be blue. There we go, like that.
Amazing. So cool. So that's a really clever way to do that. Like, so for those of you at home, just to explain a little further, what Ozzy did, he said, if I've set my humidity over a certain level, then I want you to set my variable, whatever my text color variable is, I want you to put a value in there for me, and I want it to be red. If it's less, then put a value in there, and I want it to be blue. Okay. And then when it goes and checks that, because it's determined whether the humidity is high or low, it's got the answer that it requires. It takes that, pops it into your code underneath, and changes the color of your text. Very cool. And we could have it display an image as well, couldn't we, Oz? We'd have it show like two different pictures we'd drawn. If you wanted to have like a smiley face and a sad face, you could do exactly the same. But instead of saying text color, you would have it sense.set pixels, and it would either be picture 1 or picture 2, depending on what you've got here. So we would simply just have like, if we did it, I'll show you in my one. You can see here, we might do it like, we'll change this to be picture 1, and this one here will be picture, and here will be picture, because that's what I told it to do down here. So when I sense.set pixels picture, I want it to run here, or I want it to be picture 2. Okay. And so for some of these ones, from a picture 1 would probably be the nice, if it's too hot one, it would have like a big red angry face, and my other one would have a nice green smiley face, but it will still set that depending on whatever it's detected the humidity to be. Okay, so that's how variables work. It's a really nice way that we can just take values and pop them back into our code whenever we need them without having to go and check ourselves. The code just does it all for us. And you'll see here where I've done it, I've sort of botched my entry because I've got a bunch of stuff in there that it doesn't like. Okay, so if I just get back the way it was, it should be a bit happier with me once it checks that code. Why doesn't it like it? Let's look. Okay, what have I got? If else. No, it still doesn't like it. What am I doing wrong? What have I got wrong here? Oh no, there we go. It fixed it up. I just got a bit of lag. Okay, cool. So what you've got there, everybody, is we can enter our code now. So we're going to continue to our form. So my code runs. It runs for less than the 30 seconds that I want it to run for. I've got my 3 green ticks. And we're going to continue to our form. Okay, now that my classroom code is done. And so to fill that in, we're going to put in a team name. Okay, so Team Awesome. And that's my name. I am old. And I prefer not to say it. And then I've got Mark, and so I'll add Ozzy to my team because he's on Team Awesome as well. How old are you, Oz?
I'm 13, 14 in 4 days, I think.
Fantastic. And do you want to put down as a boy, a girl? Prefer not to say.
Boy.
Boy, cool, no problem. So we've got that. That's our team, Team Awesome. And then we just have to submit our information. So we can submit our team information. Team members must be 14 or younger, so it won't let me submit, okay, because I'm too old. So if I take myself off the team, or I just change my age down so that I fit the criteria, there we go. So here that I can submit my team information. And we'll take you through to the next one, and you'll see that your program here is headed into space. It shows we've done an official submission, and you can see your program headed into space. It's going to run on mission 0. Fantastic. And it shows you here a little demo of your program running, just to remind you of what it was, and you can share your project. So if you wanted to share your project with other people, you can do that with a link. We'll bring Richard in, and he can sort of talk you through how to do that part. So how's it going, Richard?
Hey, good, thanks, guys. Some amazing code in there. I really liked your palm tree picture. That was great. Listen, just to apologise to everyone watching, it turns out what we were saying earlier about clicking through the YouTube and going in the chat won't actually work the way this is set up. One of the perils of doing live TV streaming it turns out that people can't actually enter any comments in. So really sorry about that. If you were there trying to work out how to do that, sorry if you had to mess around. Just remember that, like Mark said, the video will be available afterwards, so you can go back and rewatch it. If you do have any problems, then do get in touch with us. There'll be an email address at the end that you can email us, and we'll try and sort out your problems there. But hopefully, I think you guys did a great job of showing what the errors were and talking people through it, and hopefully not too many people are stuck at home there.
Yeah. Thanks, Ozzy. That was awesome, man. It's really great to see you code again, dude. You're a much better programmer than I am, I have to say. So, it's my pleasure, man. Thank you. So just to remind everyone that if you do choose to enter Mission 0 today or before the 19th of March, that you'll just be sharing your first name, like you saw, your age and your team name. We don't really collect anything identifiable about you, so don't worry about that. And we promise that we won't share it with anyone else, but you should check with your scout leader, teacher, or your parent that you have permission to put your name into the form and that they're cool with it. And then once you've submitted, like we showed you, your code will run in space and all that sort of stuff. So you can collect your certificates later on this year. Remember that your scout leader will get a notification from scouts to say that the certificates are online, and they can head to this web address here, but you'll also be reminded again in June when your certificates are ready. We'll tell you all about it and you'll get reminded of those URLs. So if you successfully complete your submission today, then you've just earned your Digital Maker Stage 1 badge on this session today. So congratulations to all you guys.
Yeah, fantastic job, everyone. Don't forget, you will need your team name, though, or you won't be able to get your certificate. So do remember, whatever team name you've used today, write it down somewhere, stick it on a note on the fridge or something, so that in June you can come in and you can easily find and get your certificate. Listen, that's all we have time for, really, actually. So thanks for joining us today. I hope you really enjoyed putting your code to run in space, and we'll see you all later. And don't forget, enjoy the rest of the winter camp.
Absolutely. Bye, everybody. Thanks for coming on again.
Bye.